If you want to build apps with powerful AI optimized to run locally across different PC configurations, in addition to macOS and mobile platforms, while taking advantage of bare metal performance, where your same app can run without modification or relying on the cloud, Foundry Local with the new SDK is the way to go. Today we'll dig deeper into how it works and how you can use it as a developer. I'm joined today by Raji Rajagopalan, who leads the Foundry Local team at Microsoft. Welcome.
I'm very excited to be here, Jeremy. Thanks for having me.
And thanks so much for joining us today, especially given how fast things are moving quickly in this space. You know, the idea of running AI locally has really shifted from exploration like we saw over a year ago to real production, proper use cases right now.
Yeah, things are definitely moving fast. We are at a point for local AI now where several things are converging. First, of course, hardware has gotten more powerful with NPUs and GPUs available. Second, we now have smarter and more efficient AI models which need less power and memory to run well. Also, better quantization and distillation mean that even big models can fit and work well directly on your device. This chart, for example, compares the GPT 3.5 Frontier model, which was one of the leading models around 2 years ago. And if I compare the accuracy of its output with a smaller quantized model like GPT OSS, you'll see that bigger isn't always better. The GPT OSS model exceeds the larger GPT 3.5 LLM on accuracy. And third, as I'll show you, using the new Foundry Local SDK, the developer experience for building local AI is now a lot simpler. It removes a ton of complexity for getting your apps right into production. And because the AI is local, you don't even need an Azure subscription.
Okay, so what scenarios do you see this unlocking?
Well, there's a lot of scenarios that local AI can be quite powerful, actually. For example, if you are offline on a plane or are working in a disconnected or poor connectivity location where latency is an issue, these models will still run. There's no reliance on the internet. Next, if you have specific privacy requirements for your data used for AI reasoning can be stored locally or within your corporate network versus the cloud. And because inference using Foundry Local is free, the costs are more predictable.
So lower latency, data privacy, cost predictability. Now, you also mentioned a simpler developer experience with the new Foundry Local SDK. So how does Foundry Local change things?
Well, the biggest issue that we are addressing is app portability. For example, as a developer today, if you wanted to build an AI app that runs locally on most device hardware and across different OS platforms, you'd have to write the device selection logic yourselves and debug cross-platform issues. Once you're done that, you would need to package it for the different execution providers by hardware type and different device platforms, just so that your app could run on those platforms and across different device configurations. It's an error-prone process. Foundry Local, on the other hand, makes it simple. We have worked extensively with our silicon partners like NVIDIA, Intel, Qualcomm, and AMD to make sure that Foundry Local models just work right on the hardware that you have.
Which is great because as a developer, you can just focus on building your app. The same app is going to target and work on any consuming device then, right?
That's right. In fact, I'll show you. I have built this healthcare concierge app that's an offline assistant for addressing healthcare questions using information private to me, which is useful when I'm traveling. It's using a number of models, including the quantized 1.5 billion parameter Quen model, and it has options to choose other models. This includes the Whisper model for spoken input using speech-to-text conversion, and it can pull from multiple private local data sources using semantic search to retrieve the information it needs to generate responses. I'm going to run the app on different devices with diverse hardware. I'll start with Windows, and after that, I'll show you how it works on other operating systems. Our first device has a super common configuration. It's a Windows laptop running Intel Core previous generation with integrated GPU and no NPU. I have another device, which is an AMD previous generation PC, also without an NPU. Next, I have a Qualcomm Snapdragon X Plus PC with an NPU. And my fourth device is an Intel PC with an NVIDIA RTX GPU. I'm going to use the same prompt on each of these devices using text first. I'll prompt, if I have 15 minutes, what exercises can I do from anywhere to stay healthy? And as I run each of these, you'll see that the model is being inferenced across different chipsets. This is using the same app package to support all of these configurations. The model generates its response using its real-world training and reasoning over documents related to my medical history. By the way, I'm just using synthetic data for this demo. It's not my actual medical history. But the most important thing is that This is all happening locally. My private data stays private. Nothing is traversing to or from the internet.
Right, and I can see this being really great for any app scenario that requires more stringent data compliance. Based on the configs that you ran across those 4 different machines that you remoted into, they were relatively new though. Would it work on older hardware as well?
Yeah, it will. The beauty of Foundry Local is that it makes AI accessible on almost any device. In fact, this time I'm remoted into an 8th gen Intel PC. It has integrated graphics and 8 gigs of RAM, as you can see here in the task manager. I'll minimize this window and move over to the same app we just saw. I'll run the same prompt, and you'll see that it still runs, even though this PC was built and purchased in 2019.
And as we saw, that went a little bit slower than some of the other devices, but that's not really the point here. It means that you as a developer, you can use the same package and it will work across multiple generations and types of silicon.
Right, and you can run the same app on macOS as well. Right here on my Mac, I'll run the same code. We have here Foundry Local packaged for macOS. I'll run the same prompt as before, and you'll see that just like it ran on my Windows devices, it runs on my Mac as well. The app experience is consistent everywhere. And the cool thing is that local AI is also multimodal. Because this app supports voice input, this time I'll speak out my prompt. First, to show how easy it is to change the underlying AI model, I'll swap it to 5-4 mini reasoning. Like before, it is set up to use locally stored information for grounding and the model's real-world understanding to respond. This time, I'll prompt it with, I'm about to go on a 9-hour flight and will be in London. Given my blood results, what food should I avoid and how can I improve my health while traveling? And you'll see that it's converted my spoken words to text. This prompt requires a bit more reasoning to formulate a response. With the think steps, we can watch how it breaks down what it needs to do. It's reasoning over the test results and how the flight might affect things. And voila, we have the answer. This is the type of response that you might have expected running on larger models and compute in the cloud, but it's all running locally with sophistication and reasoning. And by the way, if you want to build an app like this, we have published the code in our repo at aka.ms/foundrylocalsamples.
Okay, so what is Foundry Local doing then to make all of this possible?
There's lots going on under the covers, actually, so let's unpack. First, Foundry Local lets you discover the latest quantized AI models directly from the Foundry service and bring them to your local device. Once cached, these models can run locally for your apps with zero internet connectivity. Second, when you run your apps, Foundry Local provides a unified runtime built on Onyx for portability. It handles the translation and optimization of your app for performance, tailored to the hardware configuration it's running on, and it'll select the right execution provider, whether it's OpenVINO for Intel, the AMD EP, NVIDIA CUDA, or Qualcomm's QNN with NPU acceleration and more. So there's no need to juggle multiple SDKs or frameworks. And third, as your apps interact with cached local models, Foundry Local manages model inference.
Okay, so what would I or anyone watching need to do to get this running on their device?
It's pretty easy. I'll show you the manual steps for PC or Mac for anyone to get the basics running. And as a developer, this can all be done programmatically with your applications installer. Here, I have the terminal open. To install Foundry Local using PowerShell, I'll run winget install microsoft.foundrylocal. Of course, on a Mac, you would use brew commands. And once that's done, you can test it out quickly by getting a model and running something like Foundry model run Qwen 2.5-0.5b, or whichever model you prefer. And this process dynamically checks if the model is already local, and if not, it'll download the right model variant automatically and load it into memory. The time it'll take to locally cache the model will depend on your network configuration. Once it's ready, I can stay in the terminal and run a prompt. So I'll ask, give me 3 tips to help me manage anxiety for a quick test. And you'll see that the local model is responding to my prompt and it's running 100% local on this PC.
Okay, so now you have all the baseline components installed on your device. Now, how do you go about building an app like we saw before?
The best way to start is in AI Toolkit in VS Code and with our new SDK. This lets you run Foundry Local models, manage the local cache, and visualize results within VS Code. So let me show you here. I have my project open in Visual Studio Code with the AI Toolkit installed. This is using OpenAI SDK, as you can see here. It is a C# app using Foundry Local to load and interact with local models on the user device. In this case, we are using a Qwen model by default for chat completion, and it uses OpenAI Whisper Tiny for speech to text to make voice prompting work. So that's the code. From there, you can package it for Windows and Mac, and you can package it for Android too.
It's really great to see Foundry Local in action, and I can really see it helping out with lighting up different local AI across the different devices and scenarios. So for all the developers who are watching right now, what's the best way to get started?
I would say try it out. You don't need specialized hardware or a dev kit to get started. First, to just get a flavor for Foundry Local, on Windows, use the steps I showed with Winget, and on macOS, use Brew. Then, and this is where you unlock the most, integrate it into your local apps using the SDK. And you can check out aka.ms/Foundry Local SDK.
Thanks, Raji. It's really great to see how far things have come in this space. And thank you for joining us today. Be sure to subscribe to Mechanics if you haven't already. We'll see you again soon.